Yesterday we learned about what it looks like. So when we take an equation and we transform it, we talked about what do these transformations mean. And again, if we look at this line is shifted down 6. This one is shifted down 2. And again, don't worry about the dots. We'll use the dots on we'll use the dots next week in a couple of lessons when we learn about horizontal transformations. For now, we're just looking at how it moved up and down. This one moved up 6. This one moved up 2. This one was reflected. So we learned about these reflections. We learned about stretches and compressions and translations. So now what we're going to do is we're going to look at what are those same translations. Instead of looking at a graph, what do they look like in an equation? Okay. So when I see a vertical, so all the changes that we're learning right now are vertical. Okay. So if I see a vertical translation up, that means that B is increased. Okay, so B is increased. Okay, that means in y equals mx plus b, the B value is increasing. It's getting bigger. Okay, if I see a vertical translation down, that means that B is decreased. So B is getting smaller. Okay, and remember, we're changing from my parent function y equals x, which if you're trying to see how it's changing, you could say y equals 1x plus 0. So if I increase that, I'm going to add to the 0. So if it's increased by 3, I'll add 3, it'll be 1x plus 3. If I decrease it, I'll subtract minus 3. So let's say it's decreased by 5. I would do 1x plus 0. I'd subtract 5 from that B value. It would be 1x minus 5. Okay, so when I do translations, I'm changing B. All right. Now, when I do a vertical, there's too many I's there, vertical reflection, okay, that means that my M turns negative, or changes signs. But in the case of y equals x, I go from y equals x into y equals negative x. Because it was 1x, now it's negative 1x. So vertical reflection, my M turns negative, my slope turns negative. So when we have reflections, we're starting to change our slope. Okay? When I have a vertical compression, okay, that's going to make my M closer to 0. So it's going to become a fraction because that means it's getting smaller. My value for my slope is getting smaller because it's getting flatter. It's going to have a smaller M value. So like for example, if I compressed it, it might go from y equals x into y equals 1/2 x or y equals 1/3 x. My slope is going to get closer and closer to 0. Okay? For a vertical stretch, okay, my M will get further from 0. So it might be my y equals x might turn into y equals 2x or y equals 5x. That number is going to get further and further away. Now remember, it might be y equals negative 5x or y equals negative 3x. Because remember, all the negative tells me is if it's reflected, if it's pointing up or down. Okay, so let's look at what this looks like on some graphs. I attach these graphs to the Google Classroom so you can look at them. But if you need me to print them for you, just let me know. I can print them out tomorrow. But you can print them out from the Google Classroom too if you want to put them in your notebook. Okay. Okay. So if I look at this one, here's my parent function. If I just write the equation of this line is y equals, my rise is 1, run is 1, rise is 1, run. So my slope is 1 over 1, which is 1. So it's 1x. My y-intercept is positive 4. So this is, from my parent function, I went from y equals x into y equals x plus 4. Well, I know from the notes that I just took, if my b is increased, which it was here, it went from nothing to y equals x plus 0 to x plus 4, that means I have a vertical translation up. So this is a vertical translation up 4. Okay? So, again, I'm looking at the graph. I'm just graphing what I see, and I can confirm from looking at the graph that this equation is vertically translated up 4. Okay? Let's look at this one. This one, if I just look at the description, well, let's look at the equation, okay? So here's y equals x, my parent function. The dotted line is what I'm moving to, okay? Well, if I look at this, I've still got rise over run 1 over 1, so my slope is 1 over 1, 1 over 1, which is 1. So y equals 1x. I've got negative 2, so it's minus 2. So this is my equation. So y equals x turned into y equals x minus 2. Well, when my b gets smaller, that means I have a vertical translation down. So vertical translation down 2. Okay? So that's how I can tell from the equations. Let's look at these. These are going to be stretches and compressions. So if I look at this one, so if I look at the first one, here the dotted line is my parent function, but let's look, the solid line is my parent function. Let's look at the dotted line. Okay? Well, my y-intercept on this one is 0. My slope on the dotted line, I rise 1, I run 2. So my equation is y equals 1/2 x plus nothing. All right, so I took my y equals x and I transformed it into y equals 1/2 x. Okay, and if I look at my notes, I can see that as my slope gets closer to 0, I have a vertical compression. Now, this is the thing I told you guys I talked to you about. Vertical compression times 1/2. That means that my vertical compression, my factor, like the factor, by a factor of 1/2. You might see by a factor of 1/2. You might see like that, times 1/2, or you might see by a factor of 1/2. The slope tells you how much it's compressed. It's like your scale factor. All right, let's look at this one here. So my equation, I have a b of 0 for the dotted line. It's going through 0. When I look at my rise over run, whoops, nope, that's not right. Rise over run, because I've got a dot here, point there. I rise 4, run 1. Let's see if that works again. I rise 4, run 1. So my slope is 4 over 1, which is 4. And you should already know how to do this, okay? So my new equation is y equals 4x plus 0. Means my equation was y equals x turned into y equals 4x. When my slope, my m gets further from 0, I have a vertical stretch, which is what we see on this one. See, this is so much steeper. It's yeah. So this is a vertical stretch by a factor of 4. All right? These are going to get a little more complicated. We're going to do one easy one, and then I'm going to do a couple of like kind of more complicated ones with you. Okay, so this one here. All that's different about this one is on the first one, so the slope is 0. I mean, the y-intercept is 0. But on this one, I'm going down 1, right 1. Down 1, right 1. Which means now my slope is negative 1. So my slope is y equals negative 1x plus 0. That means my y equals x turned into y equals negative x. And when I look here, if my slope turns negative, I have a vertical reflection. Okay? Now, this one's more complicated. And again, all we're going to do is we're going to write the equation and we're going to look at what we see. Okay, so first of all, on this one, I see my y-intercept is 4. And if I look for a point, I see a point here and a point there. I rise 4, run 2. 4 over 2 works out to 2. So my slope is 2, my y-intercept is 4. Y equals 2x plus 4. If I look at that, I see that this slope is bigger than 1, because my y equals x turned into y equals 2x plus 4. This is bigger than 1, so that means I have a vertical stretch with a factor of 2. I see plus 4 on my b, that means I have a vertical translation up 4. So I've got both of these things happening. Okay, so the plus 4 adding to my b shifts it up, multiplying this by 2 stretches it, and it doubles how tall it is. All right, let's try this one. I see that my b here is -4. My slope is 1 over 2. If I rise and run, remember, don't just do it once. So my slope is 1/2, which makes my equation 1/2 x minus 4. So my y equals x turned into y equals 1/2 x minus 4. So the half x tells me I have a vertical compression. This tells me I have a translation down. Okay, so I have a vertical compression. I'm just going to put comp. A vertical compression times 1/2. I have a vertical translation down 4. Now this is the hardest one. And again, these are all examples, but this is the hardest one. Okay, so first of all, my new line has a y-intercept of 3, and the slope is, looks like -2 over 1, which is -2. So my y equals x turned into y equals -2x plus 3. So I've got 3 things here. I've got a reflection, I've got a stretch, I've got a shift up. Okay, so I'm vertically reflected. All right, I'm vertically stretched by a scale factor of 2. Remember, the negative was already taken care of by saying it was reflected. My scale factor is 2, and I am vertically translated up 3. Okay, we will practice this some more tomorrow, so we'll practice looking at the graphs, writing equations, and then describing what the equation tells us, and then we can use the graph to check it. Make sure you write down any questions you have. I know this is a lot, but write down the questions that you have, and I don't get it, it's not a good enough question. I need to know exactly what you don't get.